Hello and welcome. I'm Liesel, a proud member of the TVET team at Oxford University Press. I want to firstly thank you for taking time out of your busy schedule to join us today. Before we get into today's presentation, I would like to share with you a little bit more about Oxford University Press South Africa. Oxford, as we are more commonly known as, publishes for all educational sectors, including schools, higher education, and of course, TVET. We are an award-winning educational publisher with over 100 years of publishing experience in South Africa. Oxford University Press is South Africa's #1 dictionary and literature publisher. We publish more than 2,700 books in 11 official home languages. Our books are well researched and we pride ourselves in the delivery of high service standards. There's a renewed focus from the government towards TVET institutions and the upskilling of people and preparing them to enter the 21st century workplace confidently. We recognize the power of education to change and advance knowledge and learning by uplifting and empowering individuals. We strive in our commitment to develop and deliver high quality and affordable educational materials to learners, students, teachers, and lecturers. You, as lecturers, while you play a critical part in the delivery and the development of our youth. You stand at the front line of the educational system, and we understand that these changes and shifts as you respond to the demands of the Fourth Industrial Revolution can cause uncertainty. But by choosing to attend this presentation, you've taken the first step in responding to these changes, and it's our privilege to partner with you along this journey.
Thank you, Liesel. We're now going to go over to the delivery of the content on electronic and digital concepts for robotics.
Good day, all. This is Tembiso, one of the authors for Electronics and Digital Concepts of Robotics. We've been writing this book with my co-author, that is Brian Hendrikse. We are going to be sharing with you just the information concerning this book that we've written. We also were tasked by Oxford University Press to engage in writing this book, which is the new curriculum that will be introduced by the Department of Higher Education and Training in 2023 on robots. The main aim is to introduce the students in basic principles in digital concepts and electronics. Remember, nowadays we are living in a digital world, so many things that are going to be used, whether be equipment, machinery, instruments, they are going to be digital. So our students also have to be aligned, and also the curriculum that is being taught in the TVET sector should be aligned with the needs of the industry. As we know that most of the equipment are robots now. They can do certain work that men cannot do, and they can do it faster and quicker. These robots, they can be programmed. These machineries, they can be programmed so that they can act as robots. So this is what we are going to be covering in this particular presentation, the basic of electronics and the digital concepts on robotics. So we are going to engage myself as well as Brian once I've finished with the few slides that I will be covering. If we go to the next slide, we can see that's myself as well as Brian Hendrikse, whom we've authored this book. And if you go to the next slide, this just focuses on the main subject's aim. What are the main aims of this particular subject? The electronics and digital concepts for robotics aims to equip students with fourth industrial revolution technology, functional capabilities through the transfer of necessary trade-specific skills, knowledge, values, and attitudes for students. EDCR Level 2 covers the basics of electronics and is designed to introduce the field of learning. The assumption is made that the student has no previous electronics background. The subject focuses on the following areas of specialization: electrical power systems, electronics, digital electronics, mechatronics, and computer science. So this subject is going to be introduced in level 2 curriculum, that is NCV, for those lecturers that are going to be teaching this particular subject. It's an exciting experience, and it's an exciting subject that to teach because it's more on technology, for IR technology, which is needed nowadays for our students to succeed. If you go to the next slide, here we've tabled down the teaching time that will be required for this particular subject, so that you may, as lecturers, plan around the teaching time that is tabled down here. Then also resources management and budget that will be needed for this subject to be carried out successfully. Then here we've got topic 1, topic 2. This is just topic overview. I will be covering topic 1 and topic 2, and Brian will be covering topic 3, 4, 5, 6, and topic 7. Topic 1, SI units and intro to atomic theory. This is just the basic international system of measurement that is used for measuring the physical quantities. As we know, we've got the physical quantities that needs to be measured. So we use the basic SI units of measurement. So if you want to measure temperature, then you know which units is used. When you want to measure mass, so those are the basic measurements that are going to be looked at. And unit 1.2 only focuses on basic atomic theory. As we know that almost everything that we see is made out of small elements called atoms. So in this section, the focus will be on basic atomic theory, which will lead to semiconductors and many other things, but it starts with atoms. If we look at topic 2, is electrical supply systems, Ohm's law, Joule's law, and related theoretical aspects. Here is more on calculations, application of the measurements that we have discussed. Remember, on topic 1, we spoke about the basic units of measurement. Now the use, the application, how to use those SI units of measurement. The student will be introduced to that, and different electrical supply systems, AC and DC. So that's what the student will be introduced on. That is alternating current and direct current, the difference between the two. And as well as unit 2.3, now the application of the DC, direct current. So here we are going to be looking at calculations on the grouping of electrical cells. So the focus will be more on calculating electrical cells when they are connected in parallel, in series parallel. The student must know the working around on those calculations. So I'll hand over to Brian to continue with the next slide. Thank you so much for taking your time to listen to me. Thank you.
Good day. Topic 3, basic electronic components and semiconductors. This topic is 7 units. 3.1, the function of basic electronic components. Here you learn all the different functions of the basic electronic components. Unit 3.2, semiconductors, introduction to the silicon and germanium semiconductors. Unit 3.3, the formation of the P-type and N-type junctions, the p-in junction. In other words, how do you doctor or dope a semiconductor to make a p-type or n-type material? In unit 3.4, you learn the different types of diodes, examples like normal p-in junction diode, the Zener diode, LEDs, etc. Unit 3.5, the use and implementation of the transistors, which includes the NPN and PNP transistor. Unit 3.6 is your integrated circuits, also known as ICs. You will do the leg configuration or pin configuration of the different types of ICs. Unit 3.7, transducers and sensors. We do a lot of transducers and sensors, as most robotics are built up with all different types of transducers and sensors. All right, topic 4, electrical components, symbols, circuit diagrams, prototyping, and design. Here, this has got 3 units. Unit 4.1, we'll first start off with the symbols of electronic components and elementary circuit diagrams, simple circuit diagrams. Unit 4.2 will do construct simple circuits on breadboard and variable. And Unit 4.1, the composition and design of electrical circuits and calculations. Yes, different resistors and series in parallel, and you'll do all the calculations as well. Topic 5, electronic tools and equipment. As you use a lot of different tools and equipment in the workplace, Unit 5.1 is your basic electronic tools and measuring equipment, which includes now your side cutter, long nose, solder sucker, etc. Unit 5.2, testing electronic components. So you also use your instruments to test, for example, the resistor for its correct value, or a diode to see exactly how a diode works, etc. Topic 6, digital systems and principles. Here we'll start off with the basic digital concepts. What does a digital signal look like? How does it compare to an analog signal, for example? Unit 6.2, you'll do logic design. Here to give you an introduction to Boolean algebra, how to design a certain circuit. And in logic, in the Unit 6.3, logic gates, here you will build. You will learn all the different gates, like an AND gate, NAND gate, etc., and the truth tables. Topic 7, workshop ethics, safe use of equipment, and operational health and safety. It's divided into 2 units. Unit 1 will be the occupational health and safety concepts. In Unit 7.2, you'll do your safety precautions and procedures when placing components. In other words, what are the precautions you take when desoldering a component or soldering a component? What safety equipment must you wear when working? How to keep your workshop safe. And then we got your internal assessment and your weighting. Component, internal assessment, the weighting is 50% and your external is also 50%. Your internal ICAS counts 50% and your external, your ISAT counts 15%, and an external exam counts another 35%, which makes up a total of 100%. The ICAS is divided into 2 tests, normally written in March and June, which counts 10% each, times 2 is 20%. And then you've got 2 practical assessments which count 25% each, which is 50%. And then you've got your September exam, your internal exam, which counts 30%. Then your national assessment and weighting, you're going to write 2 papers at the end of the year. You're going to write a theory paper, paper 1, and a paper 2, a design-related paper. Now, the theory will be straight everything theory at the textbook, where the design paper will be more to design a circuit that will do A, B, C, D, E. Design a breadboard layout. Design a variable layout. Looking in more detail, paper 1, there's 7 topics in the textbook. And the paper 1 will be 15% for each topic, except for topic 7 will count to 10%, which makes up 100%. So each chapter topic counts the same 50%, except the last topic is 10%. The design paper will be 5% topic 1, 10% topic 2, and 30% for topic 3 and 4. And then there'll obviously be a digital question as well, on designing the digital circuit to do certain applications. It's count 25%. And then here's a sample national exam, 2 papers, paper 1, paper 2. There'll be 10 questions. Each question counts 10%, but we know that module 7 is only, the weighting is only 10%. So question 1, 2, and 3 will be module 1 to 6, 1 to 6, and obviously that covers all the modules, either be it true, false, or match column A with column B, or select A, B, C, D, E. It's all 10 short questions, and then there'll be 1 question on each module. Okay, then we've got 4 questions for P2, for paper 2. First 3 will be from on module 1 to 5. And 4th question will be only on module 6, which is digital design, digital circuit, do ABC. Right, and the one is the suggested time and mark allocation for both. Right, I hope you enjoyed this presentation, and thank you very much. Have a good day. Goodbye.
Good day, colleagues. So today, our piece here today, and before I get into it, I'm sitting here with our managing editor, Samira, who has worked tirelessly in the background to bring us our beautiful NCV textbooks. So these are the student books for EDCR, which is Electronics and Digital Concepts for Robotics, Programming and Robotics. And for each student book that was created, a lecturer guide is accompanying it as well. So in today's session, I will be basically checking in with Samira. What are the features, benefits and advantages that we used in the books as she worked very closely with them and her team in creating the end product, just to ensure that when you do receive the books or contemplate purchasing the books, you know exactly what it is that we have put into the books and why we have done that. So for those of you who don't know me, I'm Asif Kapoor. I am the vocational publisher at Oxford University Press. Just a little bit of background. I've come from the TVET sector. I've been in the classrooms. I've taught NCV level 2, 3 and 4, as well as the report 191, N4 to N6. So working with Samira in terms of the content, we know exactly the market and the audience that we are presenting this to. And we are quite excited about this because it is such a new but relevant subject and area for the world, not only education, and that's coding and robotics, moving into the fourth industrial and fifth industrial revolution, where technology is becoming more prevalent in today's labor market needs. So these textbooks and subjects are really geared towards skills development of our students in the NCV programs, gearing them up for the labor market. So I'm not going to spend too much time talking about the NCV landscape, but rather get into the actual crux of our books. Before we get into the books, I just want to give you a little bit of context. The NCV Coding and Robotics program is a specialized program within the IT program. So students registering for the ICT program would then have the alternative of going into a specialized stream of coding and robotics. So it still exists with your 7 normal subjects in NCV, the 3 fundamental subjects and the 4 core subjects. And the 3 for which the DHET has made a call for submissions was programming, electronics and digital concepts, and robotics. And those 3 together for level 2 will form part of the NCV program. And level 2 will be implemented in January 2023. Level 3, 2024, and level 4 finally in 2025. And we are quite excited to get started on those books as well. But we're going to stick with the level 2 for this discussion. So Amira, immediately when I open these books, not even before I open it, I'm already attracted by the colors at the top. So I'm a very color oriented person or learner and visually attracted by colors. And this makes me actually want to pick up the book and know what is inside. So what are these colors actually about?
Okay, so the colors, like you said, it's really engaging, right? Like you're thinking, okay, why the rainbow going on there? So immediately, so this is to identify each module.
Okay.
Yeah, so immediately students will know cool. If they go to the yellow, that would be module 3. So like once they've already gone through the books, they'll know, okay, there's something I needed to double check upon. Just open on top of the C, go straight to module 3.
Okay, so it's color coordinated just to help students firstly be visually attractive, those who are visually attractive to colors. And then also identify that even if I look at the top, oh, there's 1, 2, 3, 4, 5, 6, 7 colors, and I know what the colors represent, there's 7 modules within the book.
Module.
Okay, and I take it that if I'm flipping open, that these colors will coordinate with the table of contents colors as well. So if I see blue for module 1, that would be representative of the blue pages.
Exactly.
Green for module 2. Okay.
Visually appealing to the students.
And quite easily identified for referencing and indexing for context purposes. So module 3, I can immediately go there if I don't wish to use the page number allocation.
I mean, especially for programming, which is a bigger book, more pages, so then you'll know immediately, okay, go straight to the top, I don't have to go straight to the contents page. Module 3, I know.
So that's quite a nice element that was added into the design of the book.
Yeah.
That's quite interesting. And I see it's full color. So I'm just flipping through the pages and immediately I'm attracted in terms of the color and I'm just going to stop on any module. And I've got module 2.
Yep.
Okay, so immediately as I open it up, I can see that there's a double page spread consisting of units, learning outcomes, module vocabulary, and starting points. So let's look at the units and learning outcomes. What is that in aid of?
So the learning outcomes is taken directly from the syllabus.
Okay.
Yeah.
And that's the syllabus that is directly provided to us from the Department of Higher Education and Training. And we take each subject outcome or specific outcome, SO, and each learning outcome and carefully plot them in the same flow as what the syllabus has it, so that you as the lecturer as well as the students know exactly what to expect per module and all the learning outcomes that needs to happen from the start to the end of the module. And then I see we have module vocabularies and a starting point.
Yeah, so what I like about the module vocabulary is that it gives the learners the key terms that's going to be used throughout the module. And again, it's just accessible and it's like really engaging for the learners. So they'll know, okay, what key terms to look out for throughout. And then for the starting point, I think that's also just to really like engage with the learners, to give them like a relatable idea of like,
because I can see here's like two friends that are busy coding, and then the story kind of speaks in a plain language that is understood by a level 2 entrance student in terms of a problem, a real life scenario problem that exists within the story. So students are actually more attracted to a narrative or to a story, and this helps them contextualize a visual in their mind before actually starting with the actual module. And the problem, the solutions to the problem of the scenario will be found in the learning outcomes. So I kind of see why this was put on one double page spread together, so that they can see what it is they need to achieve at the end of the module, and not only what they must achieve, but why they should achieve it in terms of the solution that it gives to the starting point. And I did like a sneak peek through the book, and I saw that these module vocabularies are then identified in the actual pages of the modules, and then beautifully put at the bottom. It's highlighted in bold in the book, and then it comes across as a definition box. And that's quite cool, because the vocabulary means nothing if there's no context.
Exactly.
So now they're just introduced to the words at the beginning, but during the module, as that word pops up, they are given the definition.
Exact definition of it.
And now they can make sense of the actual context of why they are reading. Because at the end of the day, a flow chart in Excel may mean something very different to a flow chart in programming. So to give context around very general types of words helps students understand what they are reading and not just reading it for the sake of reading.
And the same goes for the storyline as well. It keeps them interested.
It keeps them engaged.
Yeah, keeps them interested, engaged throughout the module.
And then do we meet these characters? Because I know you said that they are specifically chosen to engage with learners and make it relatable. But do we meet up with these characters later in the different modules with your friends?
Yeah, some of them hang out to the next module. Yeah, even specifically with the names that we've chosen as well. We like to keep it diverse and so like as relatable as possible. So,
so there was an element of inclusivity and diversity also implemented.
I think that was also important,
keeping it local as well. Okay, so here we see that it's not only written off in the one module where you meet characters, but that the story actually integrates into the different modules as well, being passed on as if they were watching a story with different characters. And that is such a cool element.
Yeah, I really like that about this.
The book.
It's coding, but there's like a nice storyline that flows for someone of that age as well.
And it makes it a bit more engaging and interesting for students that may already, I won't say not have had programming at school, but may not have had programming in such an engaging manner at school. And now it's brought to life, call it that. Right, so if I look at different elements, there's a lot of pictures and text, and so just the pictures and text, why would I need a picture and text?
Well, I mean, for programming, specifically the subject, there's a lot of text, there's a lot of steps that you have to follow, and so the picture element was really important as well to accommodate those different learning abilities. So some students love to look at pictures, where others follow the text closely. So we just wanted to give that different elements to kids who learn differently.
Okay, and I for one must say that I'm attracted visually to the images, and then I saw another element which I'm going to now is the QR codes. And then I will get to text. So I don't know how you learn, but definitely I appreciate the element of. And although we're using programming as the main reference here, you will find this in all three books in terms of the electronics, the robotics, and the programming. So the recipe we're discussing here will filter through in all the books. And then jumping to the QR codes, I saw we had QR codes in here as well. So that to me is very forward thinking in terms of the digital age that we are living in. And I mean, everybody nowadays has a smartphone.
Yeah.
And I'm just trying to locate the QR code quickly. So that's why I'm flipping through the pages. If you can find one quickly in your robotics book, that will be awesome. But the QR codes is just adding another element to the learning experience and enhancing it. So the core material or work is captured within the textbook. So also to be sensitive to the digital divide that we do have at colleges and sensitive around data usage and things like that. The core work rests within the textbook.
Yeah.
But the QR code, have you found one in your book?
I did actually.
Awesome.
One's just there.
And then what is that QR code telling us? What a microprocessor is. So we have the text that indicates what the processor is, but for additional and enhanced learning, you can scan the code, you or the students, just to give that extra bit of definition or depth to a certain component. And these videos were carefully selected by the authors. And you can watch out different segments in terms of who the authors are, meeting them, and what they have to say about the syllabus specifically in each of their specialized areas. And then just jumping ahead, I'll save that for later.
Yeah. I just want to say another thing about the QR codes is, again, with the text, some learners also prefer the additional information. So sometimes they don't really fully grasp just on text, like what's there. So they would want to, I know for myself, if I really don't understand something, I'm going to go and Google it.
Yes.
So this is like that type of additional...
and when you search YouTube, you get all these links, and you're not too sure which one.
Yeah.
So these were carefully selected by the authors to ensure that if it wasn't a South African one, that it at least speaks specifically to the segment of work, and it doesn't overwhelm the students. Because as a lecturer, I definitely felt the value that students expressed of micro lessons in videos. So the power of videos is actually a good element to add to the learning experience. So when we look at the book, we have the starting points. I see there's multiple tasks here in as well. And they're not just all at one place, they are scattered throughout the book. So the tasks would help the students then build up their competence after learning, and we're not giving them an overwhelm of work before testing their knowledge, and we're not giving them too little work, which would be very easy then to test. So it's quite a considerable amount of content that was given first before a task, and there are multiple tasks. And definitely in the discussion that we had earlier, lecturers, we don't always have the time to do all the tasks in class, and as students ourselves once, we didn't want that overwhelm of in-class work. And you also need to give students that time to digest work and work at home or on their own as well. We saw that definitely with COVID-19, where remote teaching and learning was the order of the day, and students had to take responsibility for their work. So all the tasks, depending on your year plan and lesson plans, can be done in class, or they can be assigned as homework to students, and they are clearly laid out in terms of instructions for them to follow step-by-step guidance and have the book as the reference before attempting to do the actual tasks. And then there are certain tasks in certain books of the three that has worked out examples that helps students actually first understand how to approach a question first before we give you an activity. And this also helps you as a lecturer, where if you do not get to all the students to show them how to do an actual example, and we have some students that are faster than others, they can actually go through the book on their own. And that is what I appreciate of the different elements of the pictures and the step-by-step guidance that was given, and the screenshots. That to me was a very important element in the books, especially with the programming book. So looking at the syllabus for programming and robotics, there is the use of the Raspberry Pi, and Scratch, because I'm thinking of the cat that comes along with the Scratch program. So Scratch and Python, and we know that that is a specific software, and where the screenshots actually help students visualize and see what it is they need to expect on their screen, and also allows them to work outside of your classroom without your constant guidance there, should that save you time.
Yeah, it also gives them confidence to know that they can do it on their own because they have these guides for them. So they don't always need the help of the lecturer, like you said.
And we're not saying your job isn't important, but it's definitely the elements that are helping. And I like what you said there, the confidence.
Yeah.
And that is what we need to build up in our students as early as level 2, is building up that not only competence, but the confidence in them actually achieving something, and how better, or what a better way to achieve something than working through a problem or query on your own and achieving at the end. Okay. So talking about competence and confidence in students and building up their knowledge from what they've learned through the different activities and achieving those outcomes. Before we get to the next module, what feature do students then have once they have learned all what is needed within a module? What feature do we have at the end?
What's really nice, there's two things. There's this module summary, just a quick summary of the entire module, and then they have what's called the self-evaluation checklist.
Okay.
So it's the outcomes. So there's a cute question that says, can you, with the learning outcomes. And then it's basically the students just check what they have learned throughout the module, and if they weren't sure about something, they can go back and refer to that specific section in the book. Okay, maybe I need to go back to this section. Let me go through that again.
And what I like here in the let me backtrack. So the module summary is quite nice because you've learned quite a bit of work already, and now you're just summarizing it in quite a comprehensive way, because I can see it's not overloaded with information. It's just key bullet points of what was learned. And then self-evaluation checklist. That is what I like. So you're giving students the responsibility and ownership for their own studies. In terms of a valuable tool such as a self-evaluation checklist. And as Samira said, the checklist points are directly the learning outcomes of the syllabus with 3 columns. Can you? Yes, I can achieve this. Or no, not yet. I'm not yet there. And the no can be for various reasons. The student was absent, doesn't quite understand the concept. And beautifully, the last column is the page reference. So students can actually go back to the exact spot where this information will then be found within the module. So students have a summary plus a self-evaluation checklist that can help them ensure knowing all the work before what I see next, which is a practical task as well as a theory task. So Amira, I don't know if you know, but definitely the TVET market or landscape is very practically orientated, so very hands-on. And these subjects lend themselves to a practical nature. And the use of a practical task as well as the theory tasks help students actually combine their knowledge and use it or apply their knowledge in either a simulated environment or creating a project, or instead of just the normal true and false type of offering. So that's quite interesting at the end of each module as well. And then tell me, once the students has completed these assessments, where would I find the answers?
In the, wait for it, lecturer's guide.
Okay, perfect. So Amira has the robotics one, there's electronics, and there's programming. So in all the lecturer guides, you will have, and this we know will be key to you as the lecturer, in terms of assisting you with your workload, assisting you with resources, tools and resources to actually just immediately dive into the subject, so to speak. And each module, if I'm flipping through it, the book is also broken down into the various modules, as well as you would find it into the lecture, into the student book. But different to the student book is that you would be sitting with all the answers. And a great time saver that I see is included in here is the not only lesson plans or structure per module, but also a year plan.
Yeah.
So that actually guides lecturers in terms of the prescribed manner in which they can break down learning outcomes throughout the year. And it indicates term breaks and things like that as well. The lecturer guide is filled with valuable and useful information before actually starting with each module, in terms of your resources that you would require for coding and robotics, the weighted averages for each subject or topic, and then how it affects the ICAS and external examination as well. And then quite nicely, I see what you've added to the book as well, was the semester plan or assessment plan. And we know that these are valuable items that feature in the portfolio of assessment for lecturers and portfolio of evidence for our students. So we have these templates included in here as well. And then I'm just going to flip quickly through to one module just to
Also,
show
just
you the
another thing,
feature.
sorry, Asi. The teaching suggestions are also quite valuable.
Yes. So immediately jumping onto that, can you say how excited we are about these books? So I hope you will be excited about them as well. Is that each book opens up again with teaching suggestions and then QR codes for additional resources. So these are again valuable tools for you as the lecturer to do additional or pre-reading or additional reading, so that you also have a more broader perspective of a certain area of knowledge and not only focus on the learning outcomes. So we're giving you additional resources to that learning outcomes. And then you have your semester plan suggestions for each module, and then the answers for all the power breaks, for all the tasks, detailed screenshots, and then the end of module assessment is also provided the answers in the lecturer guide, so that you don't need to still work out the memo. And that is what you will excitingly find in your lecturer guide. So you have on offer, Samira, you can help me, that will be the 3 lecturer guides, and then your 3, I'll hold the student book for you. So we have 3 student books, robotics, programming and electronics, and then the corresponding lecturer guides for electronics, robotics and programming.
Beautiful.
So that is what you can expect with the purchasing of the Oxford range and Succeeding series. And then you can watch this in a separate segment. To bring together the knowledge, the integrated knowledge of all 3 subjects, we have developed this unique and exciting workbook, integrated workbook, and powered by Resolute Education. So Resolute Education is our industry partner that has a wealth of experience in the coding and robotics arena. And they have worked with us and our team at Oxford to put together this beautiful workbook that is step-by-step guide, pictured and broken down per term. So students would learn something, do the project for term 1. Learn, do, learn, do. But I won't give too much away in this section of the video. So catch the next section of the series of videos that will explain to you the exciting features, benefits and advantages of the workbook. So thank you very much, Samira, for joining me and taking us through the features, benefits and advantages of the book. I'm excited to have these books in my hands and actually want to register for this course. And I do hope that your lecturers, your college, your students will also benefit from these books, and we definitely look forward to answering any questions that you do have with the contact details provided within the video segment. So thank you very much, and all the best to you and your college for January 2023 with the implementation of Level 2 Coding and Robotics.
Thank you very much. If all the authors and Asif could unmute yourselves and perhaps put on your cameras, then we can turn to the question and answer section. The first question that's come in is, which software component is used in electronics, especially in the practicals?
Okay, morning. Thank you for that one, Jackie. Brian or Sitembiso, would you like to attend to that question in terms of which software is used for the practicals?
Yes. I used Fritzing in this book. And the reason why is it's a free download at the moment. And you can do a breadboard design and you can convert it to a circuit or do a circuit and a breadboard. Only downfall, it hasn't got a simulator. So, there's Croc, there's electronic workbench, there's many different software ones that you can choose from. But Fritzing is a free download at this moment. So, does that answer your question?
Yeah, I trust that successful answer. So what we have experienced throughout this whole journey of writing the book is that there is a world of software applications that can be used. And like Brian said, Fritzing, there's pros and cons for everything. So Fritzing, being the free openware software that can be used, lacks in the simulator game, whereas Croc, for example, which is a paid-for offering, has a bit more pros on that end, but that would all depend on the budget that your college actually has to spend on customized software as opposed to free software. But from the developers of the curriculum and the screeners of the book, they were very happy and even suggested the use of Fritzing. I think we will just type that into the chat as well, just so we can get the spelling correct. But if you have sampled our books, you will see that the diagrams that has been inserted in there for circuit diagrams is the general drawing type of display, as well as the Fritzing display of the circuit diagrams. So yeah, I trust that answers your questions. Thank you very much for that, Brian.
Okay, then another question is, what is the relationship between robotics programming and electronics?
Okay. I think, Brian, I'm going to throw that one your way again. Sitembiso, I will get to you. Don't worry.
Yeah. The robot itself has a lot of inputs and outputs. And these inputs and outputs are all sensors or transducers. And they have to be signally corrected so that they can give the correct output that the robot can see it. And this is where the electronics come in. This is where we design a little circuit, incorporating a transducer that will give it the correct output so that Raspberry, for example, can read, that the robot can read. Is that good enough?
Okay. No, I think you know what. The quicker we answer, and if we can answer, it will be great. And just to tie in with that, colleagues, we know that with NCV, there's always the emphasis from DHET on integration. So although we do teach our various subjects in its isolated pockets, we always get these scenarios, and we know the ISAT, for example, that tries and combines all the knowledge areas. So although you're only teaching electronics, the students themselves would need that integrated type of knowledge to help them link between electronics programming, electronics robotics, and then all three together. So for example, in I think it was Tuesday's webinar, we saw that in robotics, there are dedicated chapters, and one specifically in topic 3, module 3, that talks to electronics again. So there it covers a bit of a brief overview of circuits, symbols, diagrams, but then refers the students to the actual electronics book. And similarly, in our electronics book, so that students can make the link, we've also inserted a note there to say, please visit your robotics book to see how circuits are used and considerations to be taken when implementing electronics in robotics, and similarly in the programming book. So we created this nice type of triangle link between all three books to satisfy the concept of integration, which is quite a buzzword with DHET. So thank you very much for that feedback, Brian.
Okay, great. Then there's a question about whether you have to know programming languages such as C, C++, Python, Scratch. Are those necessary in this subject?
Okay, Brian, seeing that you're on a roll, and I'm going to reserve the last few that I see here for CTMP. So, Brian, would you like to attend to that?
No, there's no programming in level 2. However, in level 3, we will be introducing PLCs, and you will be learning ladder diagram, the language to program a PLC. But in level 2, there's no programming, strictly just electronics, digital electronics, instruments, and then a little bit of software, which is Croc or Fritzing or whatever, just designing a breadboard layout or a circuit on a software tool.
Okay, great. And then I think to specifically just answer that, lecturers. No, I don't think it would be required for lecturers to know that, to teach the electronic subject, but it would be good to have some background knowledge on that, so that you could share that within your classroom also, in an electronics classroom, should you have an enrichment period with students, so that they can also see that you as the lecturer are linking them to the world of programming. But it's not necessary that the electronics lecturer must be proficient in these languages, other than the ones that Brian indicated that will be introduced in level 3. Thank you for that, Brian.
Okay, then there's actually maybe a sort of the same kind of a question, but from the perspective of a student. For a student to be able to assemble or build the robotics projects, would they need knowledge of electronic components and how to program?
Okay, CTMP, so I think I'm going to throw that one to you, and then I will share my thoughts on that as well. What are the expectations of a level 2 student coming into the NCV coding and robotics program, specifically to electronics? What knowledge do they require?
Okay, thank you so much, Asif. For a student to be able to assemble or build robotics projects, yes, they do need the knowledge of electronics, because you remember electronics, all these 3 subjects, they are integrated, they are incorporated together. So meaning you should know electronic components, simply electronics. That's why this subject has been introduced. That is EDCR. The student must know the basic building of simple circuits in the breadboard or veroboard before they can be introduced to robotics as well as programming language. So these 3 subjects, they are very much closely related to one another. Thank you.
Okay, thank you for that, CTMP. So just to latch on to that, we do know that we get, it depends on your college's recruitment process and what criteria they use to enroll these students. Because I'll be very honest, I sometimes sat teaching computer practice with students that had never seen a computer in their life before, but they got enrolled for the program. And it is always good to work on the assumption that students have zero knowledge. And the fact that the books, that's called Basic Electronics and Digital Concepts, it introduces students from the beginning of the book to each component before getting into how to use these components, how to draw these components. And then outside of electronics, they also introduce to electrical components in the robotics subject. So they're getting various areas of pockets of knowledge. And it's always great that if students enter our classroom with that prior knowledge already of how to do circuits and what the components are, that's always a blessing. But we must always factor in that we do get NCV students that are recruited that possibly have little to zero knowledge of anything. So, yeah, thank you for that.
Right, then there's a question, when the students are done with the practical components and they want to print these on a 3D printer, how long would this take? And can you assess how many 3D printers you would need to have in a laboratory?
Okay, that's a good loaded question.
Mm.
So let's take it piece by piece. So when students are done with the practical components and want to print on a 3D print, okay. So through our journey of writing the books and things like that, we've discovered that these things are darn expensive. The 3D printers particularly, and the DHET with the release of the syllabus has put together a minimum requirement document in terms of components that are needed to ensure a good teaching and learning experience, as well as a recommended 3D printer. So a 3D printer, unfortunately, depending on your college's budget, you won't be able to supply each student with one. So similar to a computer lab that has a shared networked printer, you would most likely just need one for a class of 25 to 30. Then the prescriptions from the DHET, considering cost, budget, materials, they are to know about 3D printing and also how to print an object, but there's no prescription on what object they must print. So the way in which we set up our books, for example, if they do a practical and you are able to buy certain components, but there's one component which is quite small in nature, small in size, which we can then use to test students on the practical aspect of 3D printing. We then added a suggestion to say, instead of buying this part, you could allow students to design this on a 3D printer to complete their project. But in the end, as much as what the syllabus is laid out for you to do, there is a lot of flexibility. And in the end, as long as you reach the outcome of a student knows what the 3D printer is, a student knows how to generate a 3D printed model on the software, and a student knows how to print it, what you ask them to print, it's up to you, as long as you achieve the outcome. So in terms of how many printers per lab, I would suggest one per lab, but if your college has good funds, then two. But it also depends how many students you have in your lab. And you get different printers also, 3D printers. The bed of the printer will impact the heat, all those things has an impact. So the DHET has provided one recommendation, which is quite cost effective and will satisfy the learning outcomes for the level 2 curriculum.
Okay, and then a further question is there any extra support available concerning the use of the 3D printer, Scratch and Raspberry Pi?
Okay, so what I do know is that the DHET is providing training to colleges, but I mentioned this in yesterday's webinar. You need to check with your college community if they have submitted their name to DHET as a college to present the program next year. And what happens is the DHET then invites a group of lecturers from those colleges, which is for training held at the Tshwane University of Technology in Pretoria. They had one last week. They're having a week training next week again. And I've just been informed that they're having another session opened up in January, early January next year, for sample groups of lecturers. And in that training, they will be discussing the syllabus and things like that. From Oxford University side, yes, we are developing a professional development course, which we will use as a complement to what the DHET has already been presenting, to afford all colleges and lecturers who may not have attended the workshop or needs a refresher. And we will include aspects such as how to use 3D printing, how to use the software, how to use the actual printer, how to use Scratch, Python, and to use the component, which is the Raspberry Pi, which is needed for level 2. So we've accounted for all those levels of support, which we will be presenting in a 2-day workshop and professional development come, I'm thinking Feb. I don't want to commit to the date because it's not yet cemented, but it would be scheduled for around mid-February 2023.
Okay, then someone has commented that level 2 is ECDE and workshop practice. does that mean that when you go to level 3, students will have to choose between ECDE or robotics?
Okay. I'm just going to firstly ask Sitembiso, would you like to comment, or Brian, on that?
Yes. Yeah, yes. The level 2 ECDR, it incorporates the ECDE level 2, like in electrical subjects. It incorporates ECDE level 2 workshop practice as well as electrical principles and practice. So if you look at the book that we just wrote with Brian, those 3 subjects are incorporated in this book. So meaning few topics from ECDE, few topics from EPP, and few topics from workshop practice have been included in this new book. But for level 3, if you have chosen EDCR for level 2, then still you continue with EDCR for level 3 as well as for level 2, as Asif mentioned, that is going to in phases. Next year, 2023, is level 2 that is going to be introduced, then level 3, then level 4. So you can't, there's no choice between ECDE and because ECDE is more of electrical subjects. It's an electronic subject in electrical infrastructure course. So this one is more. It's another stream of course that is being introduced now. Thank you.
Okay, Brian, anything further to that?
Yeah, I'll just add one more,
okay.
And that is besides what Tembiso said, which is 100% correct, is also digital electronics. Understand, like Boolean algebra is not in ECDE or any other subject in electrical infrastructure. So there is some design stuff and, for example, software tools and all that type of thing, which is extra. Thanks.
Okay. Thank you, Brian. Thank you, Sitembiso. And then just finally from my side, EDCE, programming, and robotics are the core subjects. So the 4th one is the elective. So my understanding with regards to NCV structures is that the 4th one would then have the choice to either upgrade to the next level or to convert to another subject. But in terms of the program structure, your 3 fundamentals move level 2, 3, 4, and the 3 core subjects, which includes EDCE and robotics, move with the 3 levels. So there won't be a choice between the 2 when going to level 3 or level 4. Okay, thank you very much for that.
Okay, then Mapule says he can see that students are going to write P1 and P2 at the end of the year. What does P2 entail?
Okay, so quickly I'll just say, and then I'll pass over to Brian or Sitembiso both. P1 is theory and P2 is practical or design. And that is evident in all 3 subjects, programming, robotics, and electronics. So Brian or Sitembiso, what would the paper 2, the design paper, entail?
Yeah, okay, I'll start. You'll be given it's a written paper as well. So it won't be in a workshop, it'll be in a written paper. You'll design a circuit. You'll will be given a circuit. You'll make a breadboard layout on paper. You'll be given another circuit. You'll do a variable layout on paper. And then there's one other section that's on digital electronics where you will design a little circuit given certain information. And that's it.
Okay. And then just from my side, the paper 1 and paper 2 that we have inserted in the books, remember those are recommended or our interpretation of what the syllabus is requiring. So we took into account the topics that are covered, the weighting of the topics, and that it needs to be practical in nature. Based on the DHET's feedback of their reviewers, there was no feedback given in terms of this is correct or incorrect, but it was part of the approval report and all the content in the modules. So us ourselves as publishers, we definitely first want to wait on DHET to give draft copies of something before we present it in our own books. But unfortunately, given time and so forth, we have not yet received any draft interpretations of what paper 1 and paper 2 would be. And so what we've inserted in the book is our interpretation of what we could anticipate the DHET to supply. Should we get the draft from DHET, and I'm thinking earliest next year, we will definitely keep our clients, the ones that prescribe our book, we will keep them informed in terms of updates, because definitely we want our recommended sample paper to be as close as possible to what we can expect, to what students can expect. But for now, based on the interpretation of the syllabus, that is what we have produced: paper 1 for theory and paper 2 for practical.
Okay, and then there's a question about colleges trying to get quotations for the equipment, but they're struggling. And can you advise where to get the materials for all 3 subjects? I think that is over and above the books. It's the actual consumables and kits and things like that.
Okay, so again, the DHET should have received expression of interest from colleges to offer level 3 for next year, level 2 for next year. And should that college have expressed interest, the DHET should have done a site visit to say, okay, your labs currently have this, they don't have this, you need to get the following. And what the DHET has sent us is a list of 10 colleges that has been approved in terms of what they have to present the program next year. When it comes to quotations of equipment, we have an industry partner, Resolute Education, right? And they are very well versed in industry and partners for components outside of your regular supply stores. So we can gladly connect you with that industry partner to further engage on quotations for equipment. And I would take it that these would be for EDCR, your electrical components. For robotics, it would be like your Raspberry Pi and those workstation components. And for programming, I'm not too sure what additional equipment is needed there for programming outside of what NCV IT already should have. So connect with me. Jackie is inserting our details in there. So for any author or subject queries and this equipment, you can email me and I can put you in contact with the correct people. For anything marketing related, links and recordings to the webinars, Jackie will insert her information. And anything related to the ordering of sample books or the actual ordering of the books for your college, Jackie will also insert our sales manager's contact details, and we will gladly respond outside of the webinar.
Thank you, Asif. I have actually put all of those details in the chat, but you will have all received emails from me with your reminders about registrations and things like that. So you will have my email address and you're welcome to reply to that. And then I can just move the different queries, whichever direction they need to go to.
Okay, perfect. Any more questions, Jackie?
There's no more questions in the chat and we are a little bit over time. So.
Yeah, I'm just going to end off. I do see there's one that was put into the Q&A section.
Okay.
Impressed with the year planner assessment. Thank you very much. Much appreciated. Yeah, coming from the NCV background and classroom and working with Brian and CTMP so that teach in the TVET college, we do know what components are valuable to the NCV market. Can lecturers copy activities from the link to download them online? Okay, I'm definitely promoting blended and online learning for sure, but I'm not too clear on the question that's being asked.
I know the background to this.
Okay.
We've uploaded samples of the books. So that because this is a bit of a rush to get the curriculum rolled out in 2023 and the books are still being finalized before printing, lecturers can actually go in and review them online. But unfortunately, that is our intellectual property. So the books have been protected so that they cannot be downloaded or printed. So I would say no. I know Susan particularly is someone that I supplied the links to because she requested them yesterday. So at this stage, not. But I see if that is maybe a question for publishing to look at if you decide to do an ePDF, or whether activities will be available on something like EduZone.
Okay, so when it comes to the blended approach or online approach, we are converting all our student books into e-publications, which would be available on our EduZone platform. And furthermore, to the EduZone platform, our authors, Brian and Sitembiso, have also provided beautiful PowerPoints presentations per module, which can kick you off as lecturers as front of class presentations, and you can add and delete to the PowerPoint presentation as you wish, but it has been already structured and laid out. And with each module, if you look at the end of each module, there is a test your knowledge section, which has the multiple choice and things like that. Those questions plus answers are also loaded on our digital platform called EduZone. So just get in contact with your sales consultant that has your province, that's covering your province, or Liesel Jansen van Rensburg, our sales manager, to find out how you get access to the EduZone platform. And then those quizzes or activities will be loaded on that platform for your students to use and complete, to promote this blended learning approach. So thank you very much for raising that question. Yeah. So get in touch with your sales consultant to find out how you get access, you and your students, to the EduZone platform.
Great. There was a question about the presentations, but we will be sending them on to everyone who registered. We understand that often times aren't suitable for everyone, and I know I had someone contacted me yesterday who couldn't attend because of load shedding. So we are going to be sending to everyone who registered for the webinar. We just need a day or two to tidy up and make sure it flows nicely, and then we will be sending out an email with links to all 3 webinars.
Okay, perfect. Thank you very much, Jackie. Okay, so if there are no further questions, not to go too much over time, thank you very much to Brian and Sitembiso for attending today and availing yourselves to assist with the questions that our audience members had. Thank you, Jackie, for running the background coordination. And thank you to you, the lecturers, that took your time out this morning. I know it's your first day of holiday come tomorrow, so enjoy the well-deserved rest. Have a good festive and safe festive season, and we will definitely keep a lookout in your private emails and work emails for the updates that will be coming for the webinar recordings and for the professional development updates for next year, 2023. And with that, thank you very much, colleagues, and have a beautiful day further.